Mr. Hescock's physical science class. We're coming back to you again. We just covered all the different types of energy. Your warm-up question today was 3 types of energy and give me an example of each. We will have some review with 3.2 is in the Google Classroom. And today we're going to talk about how is energy changed from one form to another. Now, 3 types of energy. That could be kinetic, anything that is moving, could be like a ball falling. It can be mechanical, like a roller coaster, because it's gaining chemical. No, it's not gaining chemical. It's going up, which is gaining potential energy, but it's still moving, so it has kinetic energy. You have a combination of the two. It could be potential energy, where you store it, like stretching a rubber band or pulling back a bow. It could be chemical energy, where you store it in the bonds of atoms. It could be nuclear energy, it's stored in the nucleus of the atom. It can be electromagnetic, such as white light or infrared light, or it could be gamma rays or X-rays, and there's a whole bunch of other examples of energy that you could have given me. So let's get started. Energy can change form, but is never lost. Energy is constantly changing from kinetic to potential and vice versa, meaning back again. Plants turn light into electromagnetic, which is electromagnetic, into chemical energy, which is sugar or glucose. Potential and kinetic can be in the same system. This picture here is a pendulum. At this point, number 1, it has a high potential, but a low kinetic. At this point, kinetic is probably equal to potential. At the bottom, the kinetic is greater than the potential. As it goes up, the GPE, or potential in this case, is also going up. Kinetic is going down. And eventually we'll be up here where it's mostly potential, maybe even 0 kinetic energy if it stops at the top. So this is going to review what I just said. As a pendulum is at its highest point, it has its highest GPE, gravitational potential energy. When it falls, it converts GPE to kinetic energy. So the pendulum is going to speed up the entire time it falls until it hits the very lowest point. At that lowest point, the highest kinetic energy is reached because it's at the highest velocity. As the pendulum goes up the other side, it slows down, but it is storing energy because it is now above the ground, and therefore will be able to start gaining energy as it goes up. When the ball stops here or stops here, the kinetic energy is 0. This is probably one of the more common examples of gravitational potential energy becoming kinetic. So this is the dam, and behind the dam, this is actually the Hoover Dam, by the way, water builds up very, very high. This is much higher. You're seeing it from a much longer distance away. So as the water builds up, you build up gravitational potential energy, that energy to fall. It allows the falling water to travel through the dam and turn turbines. So when it starts to fall, it is kinetic energy. When that water is moving, it turns turbines, which is actually going to become mechanical energy. So this is an example of hydroelectric power, where you just use the power of gravity and water falling to make electricity. We, in Pennsylvania, do not have very much hydroelectric power. Most of our electricity in Pennsylvania comes from burning coal. The largest around here is out by Johnstown. They burn large amounts of coal to make heat. They take in water from the river around it, and they turn that water into steam. That steam becomes pressurized, and that steam drives turbines. And as those turbines spin, it spins giant magnets and coils, and those coils produce electricity. Now you're going from chemical energy in the coal to heat and thermal energy to steam, which is kinetic, turning mechanical and turning the turbines, and then mechanical to electromagnetic, and then sent out to your house. Solar cells. Solar cells are becoming bigger and bigger with the prices of fossil fuels going up. Solar cells use a silver and a silicon diode to convert sunlight into flowing electrons. That is, so you're taking electromagnetic energy in the form of light, and you're changing it to another electromagnetic in the form of electricity. Energy is always conserved. So when energy is converted, not all of it makes it to the new form. A lot of that energy is lost as heat. So we just got done saying about how energy, every time you convert it, is going to be lost as heat. You know, in this winter time, you rub your hands together. You feel the heat as you rub your hands. The reason that we lubricate the engines in our cars and trucks, the heat and the buildup of friction would actually destroy them. So a lot of this is caused by what we used to think was the loss of energy, but it actually is when you convert one form of energy to another, you almost always lose it in some form of heat. That is called the law of conservation of energy. Energy efficiency is very big in today's society because energy efficiency is a measure of how much usable energy after you have a conversion. So we talk about efficient machines. LED light bulbs are way more efficient than the fluorescent light bulbs or the old incandescent light bulbs that I grew up with. Hybrid cars are more efficient. They use battery power for half their time as opposed to full-fledged gasoline cars. Energy efficiency is basically you compare the energy going in and the amount of work coming out, and you'll get an energy efficiency. Modern refrigerators are more energy efficient than the refrigerators in the 80s. You can get energy efficient microwaves, you can energy efficient dryers. All of those things use less energy than ones of their equivalent size or type. All right, ladies and gentlemen. So if you have any type of energy conversion, the energy is always going to be, some of it's going to be lost as heat. Not all scientists understood this forever. They actually thought that some of the energy just disappeared. We now know better. But make sure you know, because it'll be on the test. That's the law of conservation of energy. Right now, I hope you guys get in there, get the reading done, get your homework done. And until next time, be good, be safe. I'm Mr. Hescox. See you later.